Welcome back. Previously we were discussing about theory of probability, under which we have discussed about the concept of probability, its meaning, and we were discussing about the methodological aspects of probability. Let us continue with that. Next one, mutually exclusive events. It is a quite familiar term which we have been using in our commerce areas. Mutually exclusive means if you have two or three options, these two or three options have equal probability, or equal probability means equal requirement. I hope you all know the concept of opportunity cost. If you selecting something at the same time, the next option or the next best option will be cancelled, or it is left out. So something like that. Mutually exclusive events also related to the same concept. So let's come back to the new topic. A set of events are said to be mutually exclusive if the occurrence of one of them excludes, or in terms we can say prevents the possibility of the occurrence of the other. That means if an event is followed by two options means two sample points. If one sample point occurs or happens, the next best option or the next sample point will be left out. In simple terms, with an example you will get a clear picture. If you toss a coin, we know that the result of the coin tossing will be a head or a tail. When a head appears, naturally it means that tail is left out. Tail will not happen. That is the concept. Occurrence of one event leads to the prevention of the occurrence of the other event. That is the concept of mutually exclusive events. Two mutually exclusive events cannot occur simultaneously. We know that if you toss a coin, head and tail will not come together, either head or tails. That is the concept. Getting a head and getting a tail when that coin is tossed. That is the concept and best example of a mutually exclusive events. And remember, let A and B are two events. Mutually exclusive events are represented as if A intersection B, then there will not be anything, or it is otherwise known as empty set. It is just a case study. We will discuss about the further cases regarding this concept in the application level case. Next one, exhaustive events. A group of events is said to be exhaustive when it includes all possible outcomes of the random experiment under consideration. That is, if a set of events are exhaustive, at least one of them will happen in any trial or event or an experiment of the random experiment. With an example you will get a clear picture regarding the exhaustive events. When a die is thrown, die or dice, outcome, we know that there are 6 outcomes. Either of the one of the outcomes out of 6 will happen. 1, 2, 3, 4, 5, 6. All together will form the exhaustive events because one of them will occur when a die is thrown. That is the meaning of exhaustive events. In simple terms, means events that have the chance to happen. If you throw a dice, we know that there are 6 possibilities. Each of these 6 possibilities has the chance of occurrence. That is the concept of exhaustive events. Events that have the chance of happening. If you toss a coin, we know that the outcome will be head or tail. That is known as exhaustive event. Happening of a head, it may or may not happen. That is the rest of it. But when you toss a coin, the result will be head or tail. That means the chance of happening head is similar to as the chance of happening of occurring tail. So events that are likely to happen. In simple terms, it means the chance of happening of an event out of a random experiment is known as exhaustive event. In a coin, the chance of happening is head or tail. One of them will surely happen. In case of a dice, we know that there are 6 sides. If you throw a dice by any number less than, including 6, less than 6, anything will happen. That is not an exhaustive event. Events that have the chance of happening. If you throw a dice, the chance of happening of 2 is similar to as that of chance of happening of a number 3. That is the concept. Next one, mutually exclusive and at the same time exhaustive events. It is almost similar to the concept. In this case, mutually exclusive and exhaustive events are combined together. That is the concept. A set of events are said to be mutually exclusive and exhaustive if one of them must and only one can occur. Surely it will. If you toss a coin, head or tail, one will occur. That is for sure. For example, if I am tossing 3 coins, I can toss 1 coin, 2 coin, 3 coin. If I am tossing 3 coin, I may not get all the 3 head. It may be all the 3 tail. So I may not get any heads. I might get 1 head, other 2 tails. I might get 2 heads, and I might get 3 heads. All these are mutually exclusive and exhaustive event. Mutually exclusive means if I am getting no head, that means I have definitely got 3 tails. So one will happen at the same time, other will be prevented. That will not happen. Getting 1 head, yes, that is an exhaustive event. It will happen. It has the chance of happening. Getting 2 heads, yes, there is also a chance of happening. Whenever a chance of happening of an event comes, it is known as exhaustive events. And mutually means if one event happens at the same time, corresponding other possibilities will be prevented. That is the meaning. Independent events. Usually this independent events will come as a part of practical cases. You might not get a clear glimpse about the independent events now. Anyway, we will discuss about the theoretical part. You will get a clear picture when we come across a question with regard to independent events. Usually with regard to dependency, there are 2 types of events, independent events and dependent event. We will come to the dependent event right now. Okay, an independent event. 2 or more events are said to be independent if the occurrence of one of them in no way affects the occurrence of the other or the others. For example, when a coin is tossed twice, the result of the second tossing is not affected by the result of the first toss. I hope you just got an idea about that. Independent event means we all know that every random experiment will have one outcome or more than one outcomes. Let those outcomes be events. When the happening of one event has no effect on the happening of the other, such situations are known as independent events. If in the example I mentioned now, when a coin is tossed twice, if I am tossing coin 2 times, does any effect on events due to the preceding events or the succeeding events? If I am tossing a coin 2 times, does the first time tossing affect the second time tossing? No, it will not. Does the second time toss has an effect on first time tossing? No, nothing will have an effect. So such situations are known as independent events. Whereas dependent events means when 2 or more events are said to be dependent if the happening of one of them affects the happening of the other. In case of dependent events, the chance of one event depends on the happening of the other event. That is the concept. Just the opposite of the independent event, one event is subjected to have an effect on the occurrence of the other event. Actually, you will get a clear picture while discussing the same in the case of a practical exam. Anyway, we will discuss the example. From a deck of cards, I hope you know what is meant by cards. We used to say in colloquial words, playing cheat, cheat gali like that. Okay, from a deck of cards, usually that deck of cards, cheat, it will have a 52 cards, 52 number of cards. And if I am drawing one card from that deck, we know that, and I am setting it aside. Now if I am going for the second row, think like this. For the second row, how many are there in that deck? 51 cards. There will be only 51 cards. So the probability in case of first and the probability in case of second is different, because out of 52, if I am drawing one card, one particular card, then the probability is written as 1 divided by 52, means out of 52 the probability of getting that card is 1. Just assume. And if I have selected one card from that, and if I am setting it aside, I am keeping it somewhere else. Now how many cards are there in that deck? Now it has only 51 cards. Now I am drawing again. Then what is the probability of drawing the second card? It will be written as that particular card. Let it be again 1. I am drawing only 1. 1 divided by total number of cards. What is it? What is the total number now? It is only 51. In the first case it was 1 by 52. Now it will be 1 by 51. See, there is a difference. That difference is of great importance. So the second probability is affected due to the occurrence of the first event. First event, I have drawn one card out of 52 cards. That is first event. Now in the second case, probability is 1 divided by 51. So it has a difference. So that difference occurred due to the occurrence of the first event. That is known as dependent event. I hope you understand the concept. Don't worry, we will come to that part during the practical application section. Next one, algebra of events or set theory notations. Under this head, we will be discussing some signs used in the case of practical cases. For the time being, just go through it. We will discuss in detail regarding how these notations are applicable in the practical questions. A superscript C, otherwise known as A complementary. If you have gone through the previous sessions, I hope you will know complementary. We have learned about the complementary concept in case of set theory, and A raised to C means, or A superscript C means A complementary. That means whatever you are dealing with, it does not include A. We have learned about that part in the previous class sessions. I am not going further into that. So A raised to C or A superscript C is meaning whatever you are studying about set, whatever it is a probability or it is a set, in that particular study or particular event, you are not including anything related to A. That is the meaning of this sign. Next one, A union B. A union B. It means at least one of the events will happen. That is, anything within A or anything within B. Any of the events relating to A or B, anything will be happen. Or at least one out of A or B will happen. A intersection B. That means, in the set theory we have discussed this part. A intersection B means whatever elements within A and whatever elements within B, only those elements that are common to both cases will include. So it means both A and B we include. Whatever the case probability we are dealing with, whenever you come across a sign where A intersection B means you include all those elements, or we include those elements that are present in both A and B. Next one, A intersection B raised to C. B raised to C means B complementary. The meaning of this, we are not going in detail regarding the concept of this one. Just understand this. Whenever you come across a case notation where A intersection B raised to C or B superscript C, that means whatever the probability under study, in that case you will take only the elements or items of A alone. It doesn't include B. See, earlier it was A raised to C means it doesn't include A. So automatically B raised to C means it doesn't include B or anything related to B. It only includes A. That is the meaning. This one is quite tricky. A intersection B raised to C union A complementary intersection B. It means, just understand the concept, whenever you come across a formation like this, it means only one or exactly one, any one will happen. That is the concept. Either A or either B, whatever may be the subject under the study. That is the concept. I hope you understand some of these are some of the frequent and important notation that may come across during the practical cases. We will discuss in detail each one with an equation. There are some of the equation with regard to the probability, and in those equations we will be using unions, intersection, complementaries, and like formations like this. For the time being only I am just mentioning these meaning, so we will get just a glimpse regarding these cases whenever you come across a main case. Anyway, let us go to the next one. Complement of event A. For the time being we are using a name A, actually meaning complement. Complement of an event A, that means A raised to C. Whenever A raised to C means, what is the meaning? It doesn't include A. So event does not include A. So the event A and the event not A are called complementary events. If A is an event, then not A is a complement of A. The simple meaning of the concept is, whenever you come across anything, complement of anything, that doesn't include the elements of that particular event. Here A raised to C or complement of A means whatever under study that doesn't include the items of A. In other words, you will use the term not in A or not A likewise. See, the outcomes of A raised to C will be those outcomes of the sample space of which are not in A. That means elements belonging to A will not show. We will discuss the same with an example, then you get a clear idea about that. Getting at least one head and getting no head when two coins are tossed are complementary events. Because whenever two coins are tossed, getting at least one head and getting no head. Getting at least one head means A equal to at least one head. One event will occur. And getting no head means, here we are under study means coins tossed. Let it be A. So getting no head means that is a case of complementary. That is known as A raised to C. Next one, union of two events. We have discussed this complementary unions under the heading set theory. These are important in case of probability also. That is why we are discussing again. Union of a two set. It is represented by the symbol U. The meaning under probability with regard to union of two sets means two events. Two events means at least any of the events relating to A or B. That is the meaning. Don't mix the concept we have learned in case of set theory with the methods which we are going to deal in case of a probability. Here only the concept regarding the union that term is used, but in the practical application it might be find it difficult or different. Union of two sets means in the set theory we have learned that all those items of A and all those items of B are taken together. But in case of probability, by the term union of two sets means if you are given details of A and details of B, at least any of the elements of A and or B should occur. Because here we are studying the occurrence of an event, not like the concept which we have learned in the case of a set theory. Here we are learning the occurrence of a event. Union means including all those events. So union of an event means any of the events relating to A or B should occur. That is the concept of union of event. So union of two events A and B denoted by A union B is the set of sample points in A or B or in both. For example, if A consisting of a bag, let it be a bag. A means bag having 5 red balls, and at the same time the same bag have 3 black balls. So how these events can be represented? If it is represented as a union of two events, this one is one event, this one is another event. Union of two events means either a ball from A or ball from B. So A union B means it. We learned that it includes 8 balls. That means 5 and 3, 8. The concept behind that A union B means either red ball or black ball. Any one of the balls may be selected. That is the meaning of A union B in case of probability. So A union B, instead of writing 8 balls, in the concept with regard to probability concept, it can be explained as either the red ball or the black ball. Any one of the balls has the probability of occur. That is the meaning of A union B. So just go through all these terms. We will discuss about all these terms with regard to a practical application, then you will get a clear picture regarding that concept. Anyway, just go through it, familiarize these terms and meanings. We will discuss in detail regarding each of the terms and its equations and format and notations during practical cases. If you have any queries, please let me know. We will discuss about the further cases in the next session.